Okay, so we've finished with the Scala exercises for now, but keep this terminal open. We will continue with more RDD operations. Open up a new terminal so that we can do the same steps we've done using Python this time. We're going to be working with the same README file, and because we have already uploaded that README file to the HDFS, we won't need to do it again. But if you skip through that Scala section, go ahead and upload that file now. Otherwise, start up the Spark, which is located under the Spark home/bin directory. This is now the Python shell. We can run the Python API that can invoke the Spark operations. First thing we're going to do is create the README RDD. It's also using the same Spark context, the text file readme.md. Again, that was just a transformation, so no action has been taken place yet. We do a readme.count. This will give us a count of that file, 141. And you'll notice that sometimes it doesn't go back to the prompt. Just hit enter and it'll bring you back. I just went ahead and ran the readme.first. Again, same thing. It just grabs the first line from the readme RDD. Next, we're going to filter. Use the filter transformation to find the lines with the word Spark in it. That creates the lines with Spark RDD. Likewise, you can also chain together multiple operations. So I did a filter and then I chained together the count operation to get it to return the value of 21, which is the number of lines containing the word Spark in it. Okay, so that's pretty much the same task we've done for the Python shell. Go ahead and minimize the Python shell. We will resume with Scala and focus more on some additional RDD operations. In particular, we're going to look at the map and the reduce operations. So in this case here, we're going to take the README file and have it split the line on the space in order to find the size of that line. So essentially we're doing the map operation to get it to split and then the size. The second part is to reduce the map output to find the line with the most words in it. So essentially we want to see which line has the most words, and that's what the reduce operation here is doing. So line 15 contains the most words in it. Again, I'll have to hit the enter key to get back to the Scala prompt. Now this next step, I want to show you how you can import additional libraries to do what you need to do. In this case, we're going to do the same operation we just done, but this time using the math.max function. So I imported the math library from Java, and then this line now, the map is still the same. We're going to split on the space and we're going to find the size of the line, and then we're going to reduce the output using this math.max operation. And this will show you that the results will still be the same. We just use a different route of accessing it. And in this case, we're using a library to help us accomplish the task. Spark also supports MapReduce, like as a data flow pattern. So not just the MapReduce you just saw, but the MapReduce data flow, which we'll use to do a word count. Now this is something you've all been familiar with. So in MapReduce, you actually have to code quite a few statements in order to get the word count of a file, right? In Spark, it's actually a simple chain of operations. The first thing you have to do is split the lines up individually by the words, and then you will map the word to the value of 1. So essentially, every word is going to get the value of 1, and then finally you reduce by that key, which is the word, and you add in all the values together to get you the number of occurrences of a particular word. That was just a transformation. Let's invoke an action on it. We're going to call the collect action to take a look at all the word count. As you can see here, everything is outputted on the terminal, and you can see that the words and the number of occurrences within that readme file. Now we can do the same thing with Python, so I'm going to jump back to the Python shell and show you again how to do the normal map and reduce to find the lines with the most words in it. So in Python, we're calling the map function to split the lines up and then grab the length of the number of words for that line, and then we reduce it to see which one has the greater number of words. That's what finally will be printed to the output, and it's 15. So this is the same results because we're working with the same file. Likewise, you can also use a math function of some sort. In this case, we're going to define the max function. So the max of A and B. So if A is greater than B, we're going to return A, otherwise we're going to return B. It's basically the same operations that were performed in the math.max function. Okay, so now that you have defined that max function, we're going to use it in the map and reduce to find the number of lines with the most words in it. The mapping part stays the same. We're still splitting it up and then counting the number of words, and then we invoke the reduce by passing in the max function, and in this case again it is the same number which is expected. To do a word count, we're going to do the flat map first. Flat map, what it does is it essentially breaks up the individual lines into words, and then from the individual words we do a map operation to get it to a value of 1, and then finally we're going to add up all those values to get the number of occurrences, and then we run the collect action again to see the results.